So an arc is a fraction of the circumference of a circle. So in this case, we've got a circle and we know that the circumference of the circle is given by 2 pi r. Now, if we wanted to work out the arc length, say of an arc, then we would do it in the following way. So we would have the center of the circle and 2 radii coming out from the center, and then we have an angle formed here which we can call theta degrees. So this arc is subtended by this angle. In other words, the full arc expands by this angle here. And so what we're looking at is we're looking at the distance from here to here if we're interested in working out that arc length. Then to work out that arc length, we can do the following. We know that angles around a point or angles around a circle are equal to 360 degrees. If we're just interested in this angle here, theta, then to work out what fraction of the angles in a circle are given by this here, we would have theta over 360 degrees, since that's the fraction of the circle that we have measured by this angle here. So we have theta over 360, and this is measured in degrees. And then if we want the fraction of the circumference, we know that the circumference is equal to 2 pi r, and we want theta over 360 of that circumference. In other words, we do theta over 360 multiplied by 2 pi r. That would give us the arc length given by the purple line here. So arc length equals to theta over 360 multiplied by 2 pi r, where your angle is given in degrees. And r is the radius of the circle. Let's look at an example. So the question says, work out the arc length of this sector to 2 decimal places. So we've got a circle, and within that circle we've got a sector, and we've been given some measurements here. So this measurement here tells us that the radius of the circle is 18 centimeters, and we also know that the angle subtended by the arc is given by 30 degrees. So arc length equals to theta over 360 times 2 pi r. So in this case, our theta or our angle is 30 degrees. So instead of writing theta, we would write 30. And we also know that our radius in this case is 18 centimeters. So instead of writing r, we will substitute 18. So arc length equals to, so we said theta is equal to 30, and then we're dividing by 360, and we multiply by 2 pi, and then we multiply by the radius. So the radius in this case is 18. So we can write that in brackets. And our units are centimeters. So 30 divided by 360 gives us 1 over 12. So we have 1 over 12. And then we're multiplying by 2 pi times 18. So 2 times pi times 18 is 36 pi. So we're multiplying by 36 pi, and our units are centimeters. So 1 over 12 times 36 over pi, this would become 36 over pi all over 12, which simplified gives us 3 pi. So we have 3 pi, and our units are centimeters. And now if we put 3 pi in a calculator, we should find that we get a value of, and so the question asked us to give the arc length of the sector to 2 decimal places. So we've worked out that the arc length, so this length here, is equal to this decimal, and we need to give this answer to 2 decimal places. So if we round this to 2 decimal places, we get 9.42 centimeters. And so the arc length of this sector is given by 9.42 centimeters to 2 decimal places. Let's look at this same question, but this time let's think about how we could work out the major arc length over here. And so the first thing we need to do is we first need to think about what angle this arc is subtended by. In other words, what angle do we require in the middle over here in the circle so that we can cover this whole arc? That angle would be given by, so remember, angles around a point sum to 360 degrees. We've got 30 degrees here already, so to work out this angle in the middle, we would do 360 minus 30, which would give us a value of 330 degrees. So we know that the major arc is subtended by 330 degrees. So using our formula, we have arc length equals to, so theta in this case is 330 degrees, all over 360, and then we're multiplying by 2 pi r. So in this case we've got 2 pi and our radius is 18. The radius of the circle remains the same, and our units for this are centimeters. And so simplifying this, then we've got that the arc length equals to, so 330 divided by 360 simplifies to 11 over 12, and then we multiply by, so 2 pi times 18 is 36 pi, and our units are centimeters. So 11 over 12 times 36 pi, we could write this as 11 times 36 pi all over 12, which would simplify to 11 times 3 pi, and 11 times 3 pi gives us 33 pi. So we have 33 pi centimeters. If we write this on our calculator, we should find we get, and so to 2 decimal places, our answer would be 103.67 centimeters. Therefore, the length of the major arc is given by this value here, 103.67 centimeters.